All right. Can everyone hear me okay? Thumbs up? Awesome. Thanks for coming along. Today you're going to hear from Richard and Aaron. Together they work in essentially our education and enablement arm at Jamf, helping customers and our partners tackle some of the more complex topics in our solutions that we have. Today they're going to chat a little bit about custom analytics, really cool feature within Protect that helps you extend all the things that you're provided by Jamf, but extending and enhancing them for what you're looking for in your environment. This isn't my talk, so I'm going to get off stage and welcome up Richard and Aaron. Round of applause.
So good morning, everyone. Hope you had a good evening last night at the party. So yes, hopefully we're going to try and demystify custom analytics. So we assume that you're all using Protect and you're all using the built-in analytics. Hopefully we can just go through the process of creating a custom one and try and demystify it. So my name is Richard. I'm a trainer at Jamf, and we have...
My name is Erin McDonald. I am a technical enablement manager at Jamf. We, like as Matt said, we both work with our partners.
Exactly. So you've got two for the price of one. So the agenda, or the idea is to basically go through how to build a custom analytic, what's involved. So we're going to do an initial overview of what the analytics are, and then we're kind of going to do a deep dive into things like events, data types, and the heart of the analytic is the predicate, basically. So that kind of hopefully explain what's involved, and then right at the end, we'll just cover a concept called analytic chaining. So let's start with the overview. So within Protect, we have a number of ways to monitor, report, and also potentially block malicious activity. So we're going to concentrate on analytics. So if you're new to Protect, an analytic is basically a set of rules you can enforce that will look for any defined malicious activity on the computer, on macOS, and optionally, if you've got Jamf Pro, remediate that issue. But we have other services available. Telemetry. Telemetry allows you to report system and user events on your computer. So things like people logging into the system via maybe SSH or someone running a process as root. That will get logged, and you can forward that to a third-party SIM. Advanced threat controls. These behave slightly like analytics. This is quite new. So advanced threat controls basically allow the system, or allow Protect to monitor for what Jamf Threat Labs considers unsafe activity, and it's typically kind of bad actors using built-in processes, built-in tools with macOS to do bad things. So maybe SSH sessions or things like that, basically. So advanced threat controls can monitor this and kind of auto-block that activity. And then finally, we've got unified logs. So unified logs is a central logging system in macOS, and Protect can kind of filter those logs. And again, you can pass those logs to a third-party SIM. So we've got a number of ways to report and handle malicious activity, but we're going to kind of focus on the analytics side. So in a nutshell, yeah, as I mentioned, analytics are basically a set of rules that detect suspicious activity on the computer. When that activity is detected, it raises an alert inside Jamf Protect and optionally a third-party SIM. And then as an administrator, you can investigate that and analyze what's happened and then optionally remediate it kind of through Jamf Pro. So out of the box, there are what are called Jamf Managed Analytics. So these are the built-in ones. Last count, there was 156. So each one of these will detect certain activity. But you can create custom ones. And there's many reasons you might want to create custom analytics. Every organization's environment is unique, different. So you might be looking at for a certain activity. Maybe one of the Jamf ones you want to tweak slightly to kind of tweak it to your environment. And also Jamf has a GitHub repository where they host a lot of other analytics you can kind of upload, basically. So there's many reasons why it might be useful to create these custom ones. So when you go down the route of creating these, there's a few skills that will be useful. The main one is something called NS predicate. So this is the heart of the analytic. This is basically a logical statement that defines whether the activity you're monitoring has actually occurred, basically. So that's probably the main skill. But things like regular expressions, if anyone has ever done the 400 training course, you'll come across this. But regular expressions are quite useful for things like pattern matching against directory structures and file names, okay? And also having an understanding of the event or process you want to monitor, okay? So hopefully we can clear some of this up as we go through. So to create the analytic, it's pretty straightforward. Obviously, you do this inside Jamf Protect. There's like a web interface. And as you go through, you can kind of define a number of items. So for instance, you can give it a name, a descriptive name. Each analytic has a level, which we'll come back to, but the levels basically allow you to chain a sequence of analytics together, basically, into one sequence. So we come back to that. You can set the severity, etc. There's a description you can set. And then finally, when we get to the bottom, 1 second. There you go. Okay. At the heart of it, we've got the description or the file, the event that you're going to monitor. So every analytic can have an event that you monitor. So it could be a file system event you want to monitor or a download event. So that's the activity it's going to monitor. And then below that, you have the predicate itself. Okay, so this is the heart of it. So this is what you basically use to define the activity you want to look at, basically. And there's other bunch of settings. You've got the smart group, which is basically remediation, etc. And then if you go to the bottom, you've got things called snapshots, which basically allow you to define additional criteria. So it adds another layer of conditions that can further qualify what the analytics is looking for. And there's also a snapshot option. And a snapshot basically allows you to capture the contents of a file. Because sometimes you might be interested in what's changed inside a file. So for instance, there might be a preference file, and you want to know what keys have been added or removed. So Protect can capture that content, and then you can use the predicate to have a look at what's changed, okay? So let's start with the events. So the events are basically the sensors or the events that the analytic can monitor. So there's quite a few events we can set up. Probably the most common one is file system events. So a lot of time you're looking for changes in files, preferences, basically. So that's probably one of the most common ones. But we've got things like download events we can monitor. We can monitor like gatekeeper events. And each one of these will have a set of data that's collected, a set of attributes. Okay, so if I go to the next slide. So as an example, if you select the file system event, that would capture quite a lot of detail about what happened on the file system. So for instance, it could be the path of the file that got changed, how the file was changed. Was it deleted? Was it modified? Was it a new file? There's a timestamp or when it happened. And even things like what user was involved and what process was involved. You know, maybe the file was modified by the finder, or maybe it's modified by a malicious process, basically. So all this data is available, and we can then use that data in the predicate to then kind of qualify whether a particular event was detected, okay? And there are other ones. We've got kind of various other events we can monitor, basically. And each one of these will return kind of different types of data, okay? So some less and some more, okay? So you've got things like screenshot events, you've got like download events. At the end, you've got the last one is a gatekeeper events. And again, these will capture what happened at that particular point in time, basically. Okay. So when you create the analytic, you set the event type, and there's some really good documentation. So inside the Protect web interface, if you go to the administration section, there's some really good documentation that defines all the event types, and it defines then what data is captured, okay? So it's all built in at your fingertips, which is quite handy when you're creating the analytic. So you set the event type, and then we start capturing data. Now, each piece of data has a particular type, and that type defines how you compare against it. So, for instance, there are some attributes that have a simple type; they store one value. Some attributes of data gets collected will have multiple values, and some attributes will return other more complex objects. Okay, so all this data we can capture, but understanding the type will then dictate how you access that data and compare it. So starting with some of the simpler ones, so very simple ones, some types are just numbers. We have date objects, so typically for the timestamps. There's quite a few attributes that are like logical statements, so they're basically booleans. So for instance, do we have a new file? Do we have a deleted file? So within the predicate, we use ones and zeros for true and false. So they're the simpler ones. So as an example, if we take something like the file system event, there's a number of attributes that get collected. So for instance, is new file, that's a boolean. So it will return 1 if a file was created or 0 if it wasn't. We capture the UUID of the user that's involved, which should be a number. And even something like the timestamp, which should be like a date object. Okay. So they're the simple ones. But then it gets slightly more complex. So the second type are strings. So a lot of data that's captured are basically strings. So for instance, paths to files. And with strings, we get a lot of sub-attributes that gives us a bit more information about that string. So as an example, with the file system event, there's a path object that gives us the path of the file that either got modified, deleted, etc. But there are sub-attributes on that string. So for instance, there's a length attribute that tells the length of the string. You can convert the string to lowercase, maybe for comparison reasons. And you can even extract, for instance, the file name from a path, or with path extension, get the file extension item, if that's interested to you. So they're string types. The next type are enums. So enums basically are objects that have a predefined set of values, and each value will define a particular response. So as an example, we have a type object under the file system event that gives you some more information about what happened for that event. So these are the values. So for instance, 0 was a newly created object. 1 means that the item was deleted. Okay. But be slightly careful. Some of these attributes are used elsewhere. So under the process event, as an example, there's a type attribute. And that has a completely different meaning. So as an example, that will tell you whether a process was created or whether a process was exit basically. So slightly different values. So they're the enums. Then we get more complex objects. So as an example, there's an object for users. So we get information about the user that was involved. And that contains a whole set of attributes in relation to that user. So for instance, we can get access to the user's UUID, which would be a number. We can get their UUID, which is typically a string, or the name as an example. Okay. So again, we can just kind of drill down into these objects, get a bit more information about that particular user. So we have a user type, and then finally we have a process type. So typically, some sort of process is involved when the activity happens. So with a process, again, we get a bunch of sub-attributes. So for instance, we can get the path of the process that was launched or exited. So in this example, maybe launch CTL. But then we can get details about any arguments that are passed to that process. So maybe someone is maliciously booting out or unloading a launch daemon. So we get access to the arguments. And also, we get access to the parent process. So what parent process actually launched CTL? So that returns another process for that parent, basically. Okay. And we also get information about whether the process was signed. So that returns another type called a sign-in type. And again, that gives you lots of good information about how that process, was it signed? If it wasn't signed, that would obviously be a red flag. If it was signed, who signed it? So we get the app ID, the team ID of the developer, and even what certificate or sign-in certificate was used. Was it ad hoc? Was it from the App Store? Or was it unsigned, as an example? So again, we can use all this data in our predicate to kind of qualify what's going on. So sometimes, I always like to give useful tools. So sometimes you might want to get the information about a particular bundle ID, app ID, team ID. So there's a really useful command called codesign that will let you get the sign-in information for an app. And also, there's an app called parency. This is done by the same people who did suspicious package. And that will return, again, all this information more about who signed the app and things like team ID, basically. So if you ever need that information, a couple of useful resources. And again, all these types are basically documented in the portal. Okay, so if you go to the administration section, there's a documentation section, and again, it lists all the types. Okay, and again, example values and a description of what they hold. Okay. So having got that, the heart of the analytic is the predicate. So a predicate is basically a logical statement that returns true or false, which you can use to qualify whether the event that happened is one that you're interested in, basically. So you define a set of rules, basically, and then the predicate will then be applied to all the events, and then if the event is monitored and it matches your criteria, an alert is raised inside Protect, and then you can then go on and analyze it or remediate against it. So when it comes to these predicates, all you're pretty much doing is just comparing values. So you're going to take some of the attributes you're interested in and comparing it to particular values you're interested in. So these can be simple comparisons like equals, not equals to. We got things like case and diacritic insensitive lookups. So we can basically do like a case insensitive search on a file path. We've got logical operations like true or false. We've got date constraints. We've got things like relational conditions, which are basically like partial matches. And we've even got things like aggregate operators, where we can count items. So maybe you want to count how many times a particular value or key appears in a preference file. Okay. So these are all tools at our fingertips. So to create the predicate, which is the heart of it, there's two ways you can do this. One is there's a built-in form editor. So it's basically a UI that will just walk you through creating the predicate. And this is quite useful or quite nice if you're new to this, because it's kind of contextually aware. It just kind of walk you through selecting the attributes you need, selecting the operators you need, and then you can put the values in basically. So there's a nice UI for this. Or if you're a bit more advanced and kind of used to this, there's a text box where you can just kind of maybe prepare the predicate outside of Protect and just kind of paste it in. Okay. So when we create our predicates, there are three variables we talk to. $event is probably the main one. $event holds all the attributes that was collected from that event. Okay, so this is typically the main one we access to get those values. But there's a $context, which basically has some more contextual information around that event. And then we've got $tag, which we'll look at later on. Typically, in this story, it's used for the analytic chaining piece. Okay. So we start with $event. $event basically holds all the raw data from the event that happened for the analytic. So we can access $event and then basically create the predicate around this to then dictate or evaluate whether the condition we're looking for has been met. So to dive into attributes, I'll pass to my colleague, Erin.
Thank you very much. So we're going to go ahead and take a look at some of the ways that we can, like he said, drill down further, and those are with those attributes. Now, to access those, you're going to use the $event to throw a period after that to get to those other attributes. So let's start taking a look at some of those. So we're going to look at event is new file. That is going to be one of those Booleans. 1 is true, 0 is false. For event.uid, we're going to think about our user. That will return 501 for a particular user. For timestamp, that is going to return that result with the Unix timestamp. Next, we're going to take a look at the string that we mentioned. So taking a look at string here, event path, that's going to give me that full path for whatever is contained in there. For path length, we're looking at that path that we have before. That's 48 characters. Here, we're going to switch that down with that lowercase, take out all of those capitals, replace them with lowercase letters. If we look at that path that we're seeing up there, if I use last path component, it's going to return that com.apple.loginwindow.plist. But if I just want that extension, I can use path extension. Then lastly, if I want to get everything but deleting that last path component, that'll bring me back library preferences. Moving over to user, I can enter user.uid and bring back the UUID of that user, or we can go back to that UID and get that 501. If I need somebody's name, .name. Looking at the process type of event, if I go to the path for a particular process, say that, goodness, my contact just slid out of my head, thank you. We're going to return back that particular path. If I'm looking for the arguments that could be used to run that particular process, I can gather those there within that particular array. I can also search for the parent path, that'll be the parent object, and the signing info returns the signing info of that process. Continuing on with our processes, again, returning that parent object, so parent path, bin z shell, and then the signing info for that is going to return com.apple.z shell. To do any comparison within these, say I want to look at one particular event path versus another, I'm going to use some operators. Now, here are the operators that we can use: the equal, the not equal to, greater than or equal to, greater than or equal to, as well as I can use the booleans. Again, 1 is true, 0 is false. I can also return a number, so I am comparing whether or not a UID is equal to or greater than 501. Looking at our strings, I can do a comparison. So I'm looking for an exact comparison here. It has to be the same case. It has to have everything match. I can also determine if it contains something. So in this case, I am looking to see, does this particular process contain .app? Or I can figure out if it begins with something. So in this case, com.apple. But there are more things we can do with strings, such as I can determine whether or not a string begins with a component or has something like a particular component, like library. And that'll be a wildcard, as we're showing with the asterisks on both sides. Matches, we're looking for anything that matches using a regex here to find out if anything within the system library for any user whatsoever, then library launch agents. We can also determine whether or not we want to be case sensitive or dyadic sensitive, so whether or not it has to match a particular case or not. We can skip that whole idea of the upper and lower case and use C, or if there's a possibility that we would have a character that, for example, is E, or an E with an accent on the top, using that D will strip that out, so anything that has E in it will match just fine. But maybe you don't want to do just one thing. You want to collect a whole bunch of things. Here you can use arrays. So within here, I can look for anything in that particular extension list that contains the PNG, the JPEG, or the PDF, as well as whether or not there is a particular type that is 0, 3, or 4. You can also collect the arguments within there. So for example, if I'm running a command that would contain, say, sudo or launchctl or anything that that particular process could execute, I can throw that into that array. I can also count how many of those particular arguments are going through. So in that first example, our count is returning 5. I can also return the number that is greater than a particular. So in that example, I'm going to get a count that is going to return, that is going to be more than 3, more than 0. And lastly, I can go through all of those arguments, and anything inside of there is going to return our unload or our boot out. And again, if you've got any other questions about this, there is NS predicate documentation to help you along the way. Finally, we're going to move on to our Boolean logic. We are looking at and, or, not. Simple enough. We're looking for anything that has both of those things, or one or the other, or none of those things. So to go even further, Richard's going to take us through all of our examples to explain how we can put all of these things together.
Thanks, Aaron. Okay. So let's look at some examples. So these are taken from some real analytics, some from the built-in ones, some from Jamf's GitHub repository. Just kind of give you an idea how you can kind of build out the logic for the activity you want to monitor. So the first one is one that's looking for modifications to the host file. Okay. So this is made up of two sections, really, using the AND logic. So this is using the file system event because we're going to monitor changes to this, this file. So the first part is looking at whether the event was a modified file, basically. So we're using $event is modified equals 1, so it's true. And then we have the AND logic. And with the AND logic, we then have the second qualifier. And here we got using the path attribute. So we're looking at the path of the file that was modified. We've got the C in the square brackets to do like a case-insensitive match. And then we're specifying the path to the file we want to modify. So in this case, if the host file is modified, that would turn true, and then that would trigger our analytic for then us to then go investigate. So that's a pretty straightforward one. The second one is looking for any curl activity. So anyone using curl to either download or upload content, they should be doing basically. So the first one is the type. So with the type, we can specify the type of activity. So this is a process event. So we're looking for any new processes that have been created or executed. And then to qualify that, on the process itself, we're looking for the sign-in information for the particular curl binary that Apple supplies with macOS. So we're using the sign-in information on the process, going down to the app ID, and comparing it to the known bundle ID of that process. So again, combined, this would trigger if curl gets executed. Now, one thing I would say is if you are going to create custom analytics, do test them, don't just deploy them. If you get these wrong, it can generate lots of false alerts, okay? So definitely, if you're going to test these to make a test plan, a small set of computers, just make sure you've got the logic correct in this. So that's a curl example. And then just to create one slightly longer, this one is looking for any activity where someone is using launchctl to either unload or boot out a launch daemon from memory. So maybe someone is trying to unload your security tools, as an example. So this is using the process event again. And as we dive in, we can see that it's going to, first of all, using type. So basically, the type is looking for any new process that gets created. And then we're going to qualify that with the app ID of the launchctl command line tool. Okay, so again, on the event process, we're going to dig into that just to make sure that whatever process got created matches launchctl. And then we're going to count the arguments. So how many arguments was passed to launchctl? Because what we don't want is false triggers. So if someone happens to run launchctl, maybe just for the manual page, we don't want to be triggered for that. We're only interested if someone's using launchctl and asking to do something. So we're going to just qualify that by asking where we got basically one or more arguments. And then in the argument list, we then qualify that by checking whether the unload or the boot out argument matches the arguments that we've passed to launchctl. So combined, we can then track anyone basically kicking out a launch daemon. Okay. Slightly longer one. This one is checking for screenshots. Okay, so maybe you're interested to know if someone's doing screenshots on the computer. So this is using a file system event. So we're monitoring for file system changes. So the first argument is using the type. So the type for this one is actually checking for renamed files. Now that might seem strange, because maybe you're expecting it to check for new files. But with screenshots, the last thing that happens to those files is they get renamed with a timestamp. So that's the activity it's looking for. And then it's going to qualify the file extension of that file to see whether it matches any of the known kind of graphical formats we can use screenshots for, so .pngs, .jpegs, okay. Now at this point, if we left it at this point, this would trigger for any graphical image, any picture that gets renamed. So to qualify that, we're then going to look at the process that was involved, and we compare the app ID to 2 known bundle IDs of the 2 processes that Apple used for screenshots. Okay, so this will only trigger now if those processes were involved, and we get an image that's renamed with those file extensions. Okay, so these can get quite complicated, but if you break it down logically, hopefully it makes a bit of sense. The next one is looking for any launch agents that have been created. Okay, so again, we start off with $event new file. So we're going to basically check if any new files get created. And then we have something really horrible. This is a regex example. So on the path, we're using regex to match all the locations that launch agents can exist, because there's at least 3 locations where launch agents can be deployed to. And also, the launch agent can have numerous naming conventions, okay? So this is where the kind of regex comes into play, where you can create a regex pattern to match all those locations and all the potential file names that launch agents can have, okay? So that would check for any new launch agents. However, what they do with this one is they've got an and not. So here, they're excluding particular team ID, which is Jamf, and a particular launch agent. Because if you're using Jamf Pro does regularly update the launch agents it deploys, and we don't want Protect being triggered all the time for that update. So here, they're just excluding Jamf Pro's launch agents from this analytic. Okay. So hopefully it gives you some idea how these get built out. If you go to the GitHub project I pointed you to earlier on, there's about 60 or 70 in there now. And if you look into them, it's quite a nice learning exercise to go through them and see what they use to build out that particular logic for that analytic. Okay. Then finally, we've got something called analytic chaining. So analytic chaining allows you to have a sequence of analytics. They run in a particular order. So you can have a sequence, and this is all done by the level number. So the level 0s all run first, and then you can have a set of level 1s and level 2s, etc. And the idea is you can create a sequence of analytics that will pass data from the lower one to the higher one. Okay. So it allows you to have a high level of analytics that kind of further qualifies the lower ones. Okay. Now, to create these, we use the $tag attribute. So we can use the tag of the analytics to create that sequence, and we use the level number to set the order they run. So as an example, with some of the built-in analytics, we have 2 analytics that look for new launch daemons and agents. So these are level 0s. So these will track all those agents and daemons that get created. Okay, so they've got all the logic to look for the correct directories and the correct file names being used. So these will then obviously get triggered if that activity happens. Now, on top of that, we have a level 1, and the example I've picked is this plist disguised as Apple. So some malicious players will create launch daemons, and they will disguise that launch daemon or agent as an Apple one. So they might use an Apple naming convention like com.apple for the file name. So visually, it looks like it's a legitimate Apple one. Now, with this sequence, the advantage of doing this is we can have all the heavy lifted logic we need for all the directories and file paths in the level 0s. And the level 1 just needs then to further qualify how to look for the Apple disguised ones. Okay, so it makes our level 1s much simpler because all the heavy lifting is being done for the level 0s. And it also kind of future-proofs them. If Apple ever came out and released, I don't know, added another launch agents directory as an example, all we have to do is update the level 0s, and then the level 1s will inherit that detail, basically. So to create the sequence, we set the plist disguised as Apple as a level 1, and then to connect it to the launch agent daemons, we use this $tags variable. And in there, we just compare it to the tags we're expecting or need to connect to. So those tags exist on the level 0s, And if they get triggered, those tags get passed up to level 1, and then we can just kind of qualify that. And if the tags match the ones we're expecting, we know that they have run, and then the plist disguised as Apple can then take over and kind of further qualify. So here's just an example. So this one here basically is just an example of 2 sequences. So the top one is the launch agent one I kind of showed you. And then the bottom one is basically just looking for, just kind of further qualifying it. So this example is looking for 2 named launch agents that were used in a popular bit of malware. So the level 0 will look for any launch agents. And then level 1 will have the tags variable to verify the level 0 ran. And then it can kind of further qualify the name of the launch agent based on 2 names it's expecting, basically. And then it will trigger. OK. So hopefully that was helpful. So what we've done is there was another talk, unfortunately, earlier on with one of our colleagues. He kind of builds on this talk by building out real-world workflows. So taking all this information and kind of just going through and kind of building out real-world scenario and workflows. So that should, hopefully, when it goes live online, definitely check that one out, OK? And Erin this week has been doing some labs, OK, which she's been doing. And then there's a high spot page. So if you take a picture of the URL, that's got some extra information regarding this topic, basically, on analytics and predicates, et cetera. So some extra information there. So thank you very much. I think we've got 10 minutes, so if there's any questions, we'll try not to duck them.
We do have time for some Q&A. If people do have any questions, I can stumble around the room and help people ask them out loud.
Right.
Anything at all?
No.
Great content. Thank you.
OK, thank you.
No questions?
Last chance.
It's actually the perfect content. You've answered them all. Cool. All right. Thanks for coming, everyone. Really appreciate it. Have a great rest of your day. And thanks for coming to the conference, if this is your last.